Welcome to EDU World Space.
We're given a plot in problem 74 that has some data, uh, and it is a plot where you have the potential difference on the vertical axis and the current on the horizontal axis, and it has a straight line slope for the resistance. And I've actually reproduced a portion of the plot with 2 points that I thought were very clearly marked. So those are the blue points here, and the green line is the slope. And we'll make use of this information in part A of the problem, where we're asked to find the EMF and the internal resistance. And the way to do this is to write down this particular equation, one which has, of course, the EMF and the internal resistance, which is E is equal to VAB plus IR. So we want to find two things, but we only have one equation. But the good thing about this plot is that um, any point along here will supply us with a value of I and a value of VAB. So we can have several equations. But since we have two unknowns here, let's go ahead and write down two equations. So the EMF is not changing, and let's call some V on this graph V1 and a corresponding I1, and of course the internal resistance doesn't change. And then again, write down the second equation, V2 plus I2R. So now we have two equations and two unknowns. So we can solve for E and we can solve for R. And we want to pick points V1, I1 that are particularly clear. So it's easy if you inspect the graph that the point for a current of 3 amperes, you have a potential difference of 30 volts. So that's this one point here. So that can be our V1 and I1. So I1, V1, we pick this set of points, and we can do a similar thing here where we have I2, V2 will correspond to this set of points. And so we can eliminate, so let's solve for R2, for the internal resistance first. So we can eliminate the EMF. So we just set these two equations equal to each other. So we have V1 plus I1 R1, sorry, not R1, just R, is equal to V2 plus I2R. And the idea is to solve for R. So what we can do is we can just rearrange the equation. So let's move V2 on this side and I1R on this side. So we have V1 minus V2 equals to I2 minus I1 times R. And then you can solve for R by dividing through by I2 minus I1. So let me write that over here. R is equal to V1 minus V2 over I2 minus I1. And we have all those numbers that are given by these points here. So for V1, we have 30 volts. V2, we have 24 volts. I2 is 6 amperes. And I1 is 3 amperes. And this is 6 over 3, which gives us 2 ohms. So there we have found the internal resistance. And let me just lock that off so I can solve for the EMF. So we could use either one of these equations to solve for EMF. So let's just pick the first one. So we have E is equal to V1, which is 30 volts, plus I1, which is 3 amperes, times the internal resistance, 2 ohms, and that gives us 36 volts. So we have R and we have E. So internal resistance and EMF. And now there's a second part of the problem. So let's go to the next page. Part B of the problem. And in part B of the problem, they're asking for what value of R is VAB equal to 80% of the battery's EMF. So we just found the EMF in part A, and that was 36 volts. So when VAB is 80% of 36 volts, that is 80 over 100 times 36 volts, which is 28.8 volts. And so we have VAB, and we want to find R. So we have an equation for that. So VAB is equal to high R, right? And we can find I by looking at the plot. So we have VAB is equal to 28.8 volts, and you look at the plot to see which value of I corresponds to 28.8, and when you do that, you find that I is equal to, or roughly around 3.5 amperes. So then you can find R, which is VAB over I, which is 28.8 volts over 3.5 amperes, which gives 8.23 ohms.